Okay, students, we are at the last part of the lecture and we're looking at suspension calculations and we want to explore dose titration. Okay, so we have a prescription here. When we are assessing the prescription, of course, we're going to look at the name of the patient. This is a baby of Daniel Richards. You have the date that the prescription was written. You have the patient's parameters in weight of the patient. Ibuprofen suspension is a drug that is being dispensed or requested here. Sorry, and the signature it looks busy, doesn't it? But it can be interpreted if we take it step by step. So it has a start dose and it also has maintenance dose. So the start dose says 10 milligrams per kilogram. So that means you have to convert that 25 pounds to weight. And then after that is given as a start dose, then 5 milligrams per kilogram is given 4 times a day, QID, PO, PC for 3 days. Then 5 milligram per kilogram BID, that's twice a day, PO, PC for 28 days. So in total, the person is going to be taking as much as 31 days supply of ibuprofen suspension. The first thing that is going to jump out at you is what's the BUD? The BUD is a maximum of 14 days. So we know we're not going to give the entire 31 day supply. We're going to have to determine how much of that drug regimen will we dispense and then write the copy prescription for the patient to return. So the instruction says that we are to calculate the ingredients necessary to compound this prescription, and they didn't give a master formula, but what they gave was the concentration of 40 milligrams in every 2 mils, and the available stock is going to be ibuprofen 400 milligram tablets, syrup, benzoic acid 5% stock solution, and purified water. So the first thing we're going to do is determine the signature, interpret it. So for the first 3 days, the person is going to take a particular amount of dose when we work out with kilograms, 4 times a day for 3 days. And after those 3 days, then for another 28 days, they're going to take 5 milligrams 2 times a day. Now, we have to determine based on the weight of the child, the dose. The weight of the child when converted to kilograms is 11.364 kilograms. So the start dose is going to be 113.64 milligrams, and the maintenance dose is going to be 56.82 milligrams. According to the United States Pharmacopoeia, BUD maximum is 14 days. So it means then that if the drug regimen is for 31 days plus the start dose, we can't dispense or we can't compound for the entire 31 days. We're going to have to compound for 14 days out of that 31 plus days. So therefore, the patient will be instructed to return for the remaining amount and be given 14 days supply. So let's see what this looks like. For the first 3 days, it's going to be the start dose, 113.64 milligrams plus the first 3 days supply, 56.82 milligrams times 4 times a day times 3 days. And then, because we're going to be doing 14 days out of the 31 days, the first 14 days, mind you. So the first 14 days is what we're going to dispense first. 3 out of the 14 days is already accounted for from the start dose to the 681.84 milligrams. So what amount of days is left to be filled or to be accounted for? It would be 11. 3 minus the 14 is 11. So it's going to be 56.82 times 2, because it's 2 times a day, times 11 days. Notice we're not doing 28 days, we're doing 11 days because we are doing only for 14, and that's 1,250. So the total amount of ibuprofen that will be needed will be the start dose, which is what we want the drug to start working real quick, and then the first 3 days, and then 14 days. Now I hear somebody's asking me, but miss, that's going to be more than 14 days. That's going to be more than 14 days. You are correct. It's going to be 14 days and a dose really. And it all depends on when the person is going to start taking the start dose. Because if the person start taking the start dose now, based on the first 3 days that they take it, the frequency is 4 times a day or every 6 hours. 6 hours from the start dose is when they're going to start taking the next dose. Let me say that again. You take the start dose now. Say that it's 5 o'clock now, I take the start dose now. 6 hours from now, I'm going to take the 5 milligram per kilogram or the 56.82 milligrams, because the dose immediately after the start dose, the frequency is 4 times a day, which is every 6 hours, right? So it's not me, you're going to take the start dose this minute and then you take the 56.82 milligrams the next minute. No, it must be spaced out a particular way based on the frequency of the drug following directly after the start dose. Okay, so it's going to be maybe 1 or 2 doses in excess. So that is why it's important for you to write the beyond use date on your label. The label that you're going to send to the patient, you're going to write that this drug should not be used beyond the whatever date that is. Okay, and you're also going to counsel your patient that if any is remaining, you discard in cases like this. All right, so you have accounted for the start dose, the first 3 days, and the remaining 11 days out of that 14 days. So the total amount of drug will be 2,045.52 milligrams. Now you're going to look towards the source of the ingredients. Where am I getting the drug from? The source of my ingredient is 400 milligram tablets. So it means then that even though I want a total of 2,045 milligrams of drug, I'm now going to be using not the pure drug, but the tablet. So my suspension is going to be more than what 2,045 milligrams is going to occur for. Now, I need to now determine what value or what amount of tablets will contain the total amount of ibuprofen that I need. If one tablet contains 400 milligrams of the drug, then 2,045.52 milligrams will contain 5.1138 tablets. Remember what I said, when our source of the ingredient is anything other than pure drug, tablet or capsule, we use whole numbers. Worse if it's capsule, because you can break the capsule in half. Well, I mean, you can break it in half, but you won't get, it's not a solid powder inside the capsule, right? So you're going to have to use whole capsules or whole tablets in this case. I have 5.11 tablets. All the nerves and cells in your body saying, Ms. Price, we need to use 5 tablets. No, because 5 tablets is going to contain less than 2,045 milligrams of ibuprofen that you want. So you have to maintain 5.11 or use greater than 5.11, which would be 6 tablets. Because in this earth, on this earth, we cannot accurately obtain 5.11 tablets in your pharmacy or in whichever institution you are at. We are going to have to use whole numbers. All right, so we're going to use 6 tablets, 6 whole tablets. So this is going to change the dynamics of the volume now. So how are we going to determine the volume? We're going to be determining the volume from the concentration as outlined in the question, which is 40 milligrams per 2 mils. So if 40 milligrams is contained in 2 mils of suspension, then the amount of drug that we want, total amount of ibuprofen, which is 2,045.52 milligrams, will be in X, which is 102.276 mils. But the 2045.52 milligrams is equivalent to 5.11 tablets. So it's another way of saying it then would be 5.11 tablets will also be contained in 102 mils. But we're not using 5.11 tablets, what we're using 6 tablets. So therefore, 6 tablets will be contained in X, and that would work out to be 120. Notice 120 versus 102. It's about 18 mils more than what would have been required if you were using a pure drug. Okay. Another way of doing this would be to determine how many milligrams would be contained in 6 tablets, and you just work it using the milligrams rather than using the tablets. Either way, it's okay. So now that we know what the volume is, which is 120 mils, the adjusted volume, we now will have to determine the amount of preservative to use. We're using a good old benzoic acid. And of course, benzoic acid that is used is 0.1% in final preparation. So therefore, we need 0.12 grams of benzoic acid to be added to your suspension to make it, or to be included in your suspension to make it preserved for the 14 days. But alas, we do not have 0.1201 grams of pure benzoic acid powder. What is it that we have? We have 5% stock solution. So therefore, if 5 grams is in 100 ml of that solution, then the 0.1201 grams of benzoic acid that we want will be in 2.402 ml. Yeah? So you see, concentration comes in everywhere. So all that you have learned before is now underpinning what you're doing now in terms of dosage form and compounding and dispensing. Very important that those concepts are solidified. When we're calculating for sweetener, we recall that we use between 10 and 30% in our final preparation. So therefore, we're going to end up using 12 mils. All right? Do we calculate for water? Nay, I say. We do not calculate for water because water is a vehicle and we are adding sufficient amount of water until we reach 120. So your ibuprofen, 400 milligram tablets, you're going to be using 6 of them. Benzoic acid 5% solution, because if you use a pure benzoic acid powder, you use a stock solution that will furnish you the benzoic acid that you need in the final formulation will be 2.4, syrup will be 12, and of course purified water adds up to a final volume of 120 ml. So this is pretty straightforward, nothing too challenging. The only challenge would be 1, to interpret the signature accurately, 2, to be able to remember that the BUD is maximum 14 days, 3, to determine the source of your ingredient, because the source of your ingredient is going to determine whether or not you're going to adjust a certain volume or you're going to maintain the volume based on the total amount of drug you calculated. If you're using the pure powder, you're going to use the exact amount of suspension that you need for the drug regimen you calculated for, which is 14 days or less. If you use another source of the active ingredient, which would be the tablet or the capsule, it means then that the amount of suspension or the volume of suspension that you are going to be calculating for is going to be more than that which you would have calculated for if it was a pure drug. All right, so these things you have to take into consideration. You also have to take into consideration whether or not a suspending agent is included in the stock listing or in the master formula. If a master formula is given, you also have to determine whether or not a concentration was given to you so that you could use, or you have to come up with your own concentration. If you come up with your own concentration, which is most likely going to happen in practice, you have to take into consideration the age of the patient. If the patient is a neonate or a newborn, by God, you're not going to be giving 10 mils, each dose to be in 10 mils. It will be like 1 mil or 2 mils. If the patient has fluid restrictions as an adult and the doctor says, look, can't get any more than 100 ml of suspension, you're going to have to work within those boundaries, and therefore you're going to have to choose a concentration that's appropriate for that patient. Generally speaking, for children and adults, 5 mils is sufficient. From there, there are 2 years and up, okay? But that's not set in stone, as I would have explained to you. It all depends on the patient and the nature of the dosage form, etc. All right? So we're at the end of all the pieces of lectures. We had 6 parts of lectures on suspensions today, and therefore we're going to have to test whether or not you understand what has gone on here. So therefore you are going to be required to do some work on Moodle in this case. Okay, so let's summarize dosage forms. One, suspension is a heterogeneous liquid dosage form that contain finely divided insoluble particles that are suspended in a vehicle, and the vehicle may be aqueous or non-aqueous in nature. Your vehicle may be water, your vehicle may be syrup, your vehicle may be alcohol, maybe an oil. Suspensions may be oral, or it may be for external use. And the active pharmaceutical ingredient may be the pure powder, or maybe sources of the active ingredient may be available, such as tablets or capsules. Extemporaneously compounded suspension that contains water, not only suspensions, solutions as well, should have a beyond use date of no more than 14 days and should be kept refrigerated. The excipients that are used include preservatives, suspending agents, sweeteners, flavorants, vehicles, etc. There are other things like colorants and those things, which we will not going to be introducing here because that is more into the realm of pharmaceutics, which we're not really doing here. All right, so you have successfully learned how to calculate ingredients needed to prepare an extemporaneously compounded suspension, and I'm very happy that you will be able to apply this knowledge going forward.